In our previous lesson, we took a look at how we could solve a system of equations using its graph and its table to find the point of intersection and therefore the solution of a system. Today we're going to take a look at another method called substitution. Now remember, the substitution property of equality says if A is equal to B, then I can replace A for B in any equation or expression. Likewise, I could also replace B for A in any equation or expression. So let's see how we can use this substitution property to solve a system of equations. In example 1, we're told that the stadium has a seating capacity of 4,216. We're also told that there are 4 times as many lower level seats as there are upper level seats. We're also told that there are 3 times as many mezzanine seats as there are upper level seats. How many of each type are there? So let's establish some variables. L is the number of lower level seats. Let's say U is the number of upper level seats, and M is the number of mezzanine seats. All right, I know that together L plus U plus M has to equal the total number of seats in the stadium, which is 4,216. Now I'm also going to write an equation from this sentence here that says there are 4 times as many lower level seats as there are upper level. So that means 4 times the upper level will equal the number of lower level. I also know that there are 3 times as many mezzanine seats as there are upper levels. So likewise, I can write the equation 3 times the number of upper level equals the mezzanine. Now, I see that L is equal to 4U and M is equal to 3U, so I am going to substitute 4U in for L and 3U in for M to my original equation. So I will see I have 4U plus U plus 3U should be equal to 4,216. Now I have one equation with one unknown, or one variable, U. I can combine all those like terms. That gives me a total of 8U is equal to 4,216. Now when I divide to solve for U, the number of upper level seats that I'll get should be equal to 527. Okay, now let's go back and let's find the number of lower level seats by substituting 527 in for U. And I will get 4 times 527. Gives me the number of lower level seats, and that should come out to equal, what is it here? 2,108. And finally, my mezzanine seats would be 3 times that 527. That will equal my mezzanine, and I get 1,581. So there's an example of how we can use substitution to find a system of equations with our 3 equations right here in the middle. All right, let's take a look at another example. I see here in example 2, it says solve the system using substitution. I see that I have y is equal to 3x, and I also see that I have x times y is equal to 48. Well, because y is equal to 3x, I'm actually going to take that 3x and replace y with that value. And I'll write the equation x times 3x is equal to 48. Next, I'm going to multiply x times 3x, and when I do that, I get 3x squared is equal to 48. And now I can solve for x. I'm going to divide off 3 from both sides, and I get x squared is equal to 16. Next, I need to take the square root of both sides, and when I do that, I have to allow for both the positive and negative solution to be true here. So I say my solution is both plus and minus 4. All right, moving on to example 3, I have another system of equations here, and I'm going to solve this system using substitution as well. So I see that I have one equation already written in terms of one variable x, so I can substitute this expression 3 minus 2y into my second equation wherever I see x. So let's rewrite that by saying 3 times the quantity 3 minus 2y plus 6y is equal to 6. Now we can distribute that 3 inside that parentheses to get 9 minus 6y plus 6y is equal to 6. Oops, that's supposed to be a 6. So an interesting thing happens here. I have both a negative 6y and a positive 6y. Well, when I combine those both cancel each other out because they're additive inverses. And I'm left with just 9 is equal to 6. Now, this is not a true statement. 9 is never equal to 6. So what happened here is I ended up with no solution. In fact, if I were to graph these two linear equations, I would find out that these are probably parallel lines, and therefore they'll never intersect, and that's why there's no solutions. All right, in our final example for today, we're going to solve a system using substitution, and now we're back to having 3 equations. So I see here that I have a y that's written in terms of x, so I can substitute 4x minus 20 into this first equation here where I see y, and I also see that 3x is equal to 2z. Well, I have a 2z in this first equation as well, so I can just replace 3x in for that 2z because 3x is equal to it. So let's rewrite that top equation now. It will say 3x minus the quantity 4x minus 20 plus 3x is equal to 26. All right, now be careful here. We have a minus sign out in front of the parentheses, so we need to distribute that minus sign in. So I now have 3x minus 4x plus 20 plus 3x is equal to 26. Now when we go ahead and combine like terms, we'll have a 3x and a 3x. It gives me 6x minus 4x gives me a positive 2x plus 20 is equal to 26. When I subtract my 20 over the other side, I get 6, and therefore x is 3. Now we can take that value of x and we can substitute it back in for these other equations to find out what the values of z and y are. 3 times 3 is equal to 2z, therefore 9 is equal to 2z, and therefore z must be equal to 4.5. And finally, we can substitute our value for x into this middle equation here to find our value for y. So we see that y is equal to 4 times 3 minus 20. That's 12 minus 20, or in other words, y is equal to negative 8. So the solution to this system are the letters x, y, and z, and the way that we would write that ordered triple out would go like this, in parentheses 3, comma, negative 8, comma, 4.5. And there's the solution to this system of 3 equations.